Hey everyone, and welcome. So, you're writing code in Go. You know how important it is to keep it clean, efficient, and secure. But let's be honest, how do you really know if you're catching all those little bugs or potential security risks? Well, today, we're going to tackle that head on. We're diving into SonarQube and getting it plugged right into your Go project step by step.
I want you to think about this for a sec. Is your code really as clean as you think it is? We all write code that feels solid at the moment, right? But you know how it goes. Hidden issues can be lurking just under the surface, just waiting for the worst possible time to pop up. So how can we be sure we're not missing something? So here's our plan for today. We'll start with what I'm calling the code quality quest, basically why this all matters. Then we'll get to know our main tool, SonarQube. After that, it's all hands-on, setting things up, prepping your project, and then the best part, running the scan and seeing the payoff. I really want you to think of this whole process like a health checkup, but for your code. You know, you go to the doctor for a checkup to catch potential problems early. Well, that's exactly what we're doing here, making sure our code is healthy, secure, and not going to give us headaches down the road. And what exactly are we looking for in this checkup? Well, we're on the hunt for all the common ailments. You've got your hidden bugs that somehow slip past testing. You've got security hotspots, which are basically ticking time bombs. And then there are code smells. You know, those little things that aren't technically bugs but make the code an absolute nightmare to work with later. All this stuff plus inconsistent standards and low test coverage just chips away at your project's foundation. So to find all these sneaky issues, we need a really powerful tool. And that, my friends, is where SonarQube comes into the picture. Just think of it as our super advanced diagnostic machine. It's going to give us a full spectrum analysis of what's really going on inside our code.
So what is SonarQube, really? Well, at its heart, it's a platform for continuous code quality inspection. It totally automates the review process using what's called static analysis. That just means it scans your code without actually running it to find bugs, vulnerabilities, and all those nasty code smells. It's like having a super picky, brilliant developer looking over your shoulder at every single line of code you write. Okay, enough theory. It's time to roll up our sleeves and actually set up our diagnostic lab. First things first, we've got to get the SonarQube server up and running, and then we need to install the scanner that's going to talk to it. Don't worry, the setup process is actually pretty straightforward. We're going to use Docker to fire up the server. It's the easiest way. Then we'll install Java, which the scanner needs, grab the scanner tool itself, and finally, do a little tweak to our environment to make it super easy to use. First up, the server. And trust me, the absolute simplest way to get SonarQube running on your machine is with Docker. This single command does all the heavy lifting. It pulls the image, starts a container, and makes the SonarQube web dashboard available on port 9000. Easy peasy. Next, the scanner tool we're going to use is actually a Java application, so it needs a Java development kit to run. A quick little apt install command like this will get that dependency knocked out in no time.
Okay, now for the scanner itself. We're just going to grab the SonarScanner command line tool right from their website using wget, and then unzip it into a standard location, like opt. Now, this next step is a small one, but it's a huge quality of life improvement. We're going to add the scanner's bin directory to our system's path. What that means is you can just type SonarScanner from any project folder, and it'll just work. No more typing out that long, annoying file path every single time. And for the moment of truth, to make sure everything is set up correctly, just run SonarScanner-V. If you see a version number pop up in your terminal, congratulations. Our diagnostic lab is officially open for business. All right, our tools are all set up and ready to go. Now it's time to prep the patient, our Go project. We just need to give SonarQube a little bit of information about our code before we can let it do its magic. To do that, we're going to create a simple configuration file in our project, usually called sonarproject.properties. This file tells the scanner everything it needs to know. You'll give it a unique project key, tell it where your sources are, and this is super important for Go. You have to point it to your test coverage and test result reports. And that brings up a really key point. SonarQube doesn't run your tests for you, it just analyzes the results. So our first step is to actually generate that data. We can do that with a standard Go test command, but with one crucial addition, the -cover profile flag. This creates that coverage.out file that SonarQube is looking for. Okay, the prep work is officially done. Our project is configured, our reports are generated. Now for the moment we've been waiting for. Let's run the final scan and see what our diagnostic machine has to tell us. This right here is the command that kicks the whole thing off. We call SonarScanner, and we just pass in two critical pieces of information. First, the URL of our local SonarQube server, and second, a login token for authentication, which, by the way, you can generate really easily from the SonarQube web UI. This one command sends all of our code and our test data up to the server for a full analysis. After a few seconds, you're going to see this beautiful message in your terminal, analysis successful. This is it. The scanner has done its job, and it even gives you a direct link right to the dashboard, where you can see the complete, detailed health report for your project. And what a report it is! The dashboard gives you so much actionable information. You'll see any bugs it found, any security hotspots you need to investigate, and it'll even count up all the code smells. But for me, the real gold is the hard numbers you get for your test coverage percentage and, my favorite, a maintainability rating. This tells you how hard it would be for a brand new developer to jump into your code. That is an absolutely critical metric for any team that's growing. So there you have it. You now have the full playbook to run a deep, comprehensive health check on any of your Go projects. So go ahead, try it out on your own code. The only question left is, what's SonarQube gonna reveal? Thanks so much for joining me.